Okay, hello everyone, I am Shoumitro. So this will be my first video lecture with you. Um, in this week we will be talking about rectifiers in a little bit more detail. You have already known about rectifiers from your Adrita Mrs. lecture from previous weeks. So before getting into the details of rectifiers, we will review a bit about what you have learned about rectifiers until now. Okay, so yeah, rectifiers. So what are rectifiers? Well, rectifiers are basically some circuits that can convert AC signal or alternating current signals to DC signals. All right, suppose you have some AC signal and you pass it through this circuit, and this circuit gives you as output a DC signal. All right, okay. So these circuits are called rectifiers. Why do you need rectifiers? As you already know, that all of our devices, the electronic devices that we use at our homes, whether it be smartphones or computers, basically any appliances that we have electronic circuits in them, all run on DC signals. We need DC signals to charge the batteries within them, and once you get to study transistors, you will see that transistors, we need DC signals to operate transistors. This is basically the principal reason that all of our electronics devices run on DC signals. All right, but the power that we get from our wall warts or the power lines that we have at our homes, all of those supply AC power. So to run all of our appliances, we need DC power, and so to convert that AC power to DC power, we need rectifiers. So the question may come that, okay sir, then why do we need to supply AC power in the first place? Why can't we supply DC? Can't we just generate and supply DC power? Well, as you have learned from your previous lectures, that the power that we have at our home is not actually generated close to our houses. It is generated in a coal power plant or a hydro power plant far away. All right, so we need a mechanism to transfer that power from a large distance to our homes. Okay, but the thing is that since this power comes from a large distance away, there are power losses in the transmission lines that we have. Okay, transmission lines that we have. In fact, in some cases, these transmission lines are hundreds of kilometers long. So suppose if you supply some meager 20 to 30 volts from the generator to supply to your home, all of this voltage might get dropped across the transmission lines, and you will actually get no power at your homes. So to have any reasonable efficiency to supply across transmission lines, we need to transmit this power at a large voltage. Okay, we need high voltages to supply using transmission lines. Okay, suppose the power that we use at our homes, our wall plugs actually supply about 220 volts, but the transmission lines don't actually supply power at 220 volts. Actually, the transmission lines that we have in our country supply at several kilovolts, about 2000 to 2500 kilovolt, 2500 volts. Okay, power is supplied through these transmission lines at a very high voltage. This is done in order to reduce the line losses in the transmission lines. Okay, so the higher the voltage at which you supply power, the lower the drop will be across the transmission lines. Okay, and it is a very interesting fact that when the electrical power lines were being made in the late 1800s and early 1900s, there was no mechanism to make high voltage DC. Okay, there was no way to produce or convert to high voltage DC. High voltage DC. Okay, as you see that we need to do transmission at a high voltage, we need to use at a low voltage. So we usually generate at a lower voltage, transmit at a higher voltage, and then again use at a lower voltage. So we need to do voltage conversion several times in our supply or transmission of electric power. But when these power technologies were being developed in the early days, there was no way to actually do these things using DC. But AC voltages can be easily transformed from low voltage to high voltage, again to low voltage, because there exists a very simple device that can do this thing, and that device is called a transformer. Okay, because of the existence of this simple device, all of our power generation equipment and power transmission equipment were laid out in AC. If there was any analogous technology for DC voltages, perhaps we would be using DC now for transmission technologies, but they didn't have that technology at that time. Because we can use transformers to easily transform AC voltage from low voltage to high voltage, we decided to transmit all voltages using AC signals. Okay, but there has been some very recent developments in this field, because now we have some very sophisticated electronic circuits that can transform low voltage DC to high voltage DC. Okay, and it is another interesting fact that high voltage DC is actually more efficient than low voltage DC. Sorry, high voltage AC. Okay, so high voltage DC is more efficient than high voltage AC. So if we can transmit at very high DC voltages and then have some mechanism to convert that high voltage DC to low voltage DC, then that will actually be a more efficient power transmission technology. And China has actually implemented this high voltage DC transmission power lines. Okay, in fact, recently, maybe last year, China has started a 1.2 million volt transmission line, and that is an HVDC transmission line. Okay, so yeah, that is the state of the art of current power distribution technologies. Okay, so that was the brief history that why we transmit AC, why can't we transmit DC? Because we need to maintain a certain amount of efficiency in our transmission lines, and we need to reduce losses. But the appliances that we use can't use that AC signal, so we have to convert our AC power to DC power, and for this reason we need rectifiers. Okay.